In this demo, we will show you a digital twin of the performance of a building construction, and how using DKube QueriLynx you can get accurate insights from the digital twin without using any SQL. Construction projects generate vast amounts of structured data across environment, resources, safety, and energy, but accessing that information usually requires technical expertise. With QueriLynx, you can simply ask questions in plain English and instantly get factual, data-driven answers, making construction intelligence accessible to everyone. In this demo, we have the building performance dataset as a digital twin, which is approximately 50,000 data points collected at 1-minute intervals regarding various aspects of a construction project. This database contains two tables: the construction project dataset table containing data regarding operations and outcomes, such as worker count, safety incidents, etc., and the construction project performance dataset containing data regarding site and environment context, such as temperature, humidity, performance score, resource utilization, etc. Both tables have a common timestamp key, which can be used to connect them. Here, QueriLynx essentially acts as a digital twin stream for construction data, consisting of environment, resource, production, safety, and energy-related data. Let's now query the database. To start with, let's ask, which week had the highest temperature recorded? QueriLynx finds the appropriate answer and provides it instantly. It also generates a graphical representation if needed, and also shows the agent's thought process and the SQL query generated and used to retrieve the appropriate answer from the dataset. Next, let's ask a question regarding safety incidents. How many safety incidents occurred during each day of the first week of January? QueriLynx refers to the appropriate dataset table and retrieves information regarding all safety incidents that occurred during the first week of January. It also provides a graphical representation of the same insights, the thought process behind the multi-agentic solution that generated the answer, and the SQL query used to retrieve the information from the database. Let's ask another question. For the last 7 days of January, compare daily averages of energy consumption. Once the multi-agentic solution gathers the database schema, generates, validates, and executes the SQL query, the summary response is generated. Also, the visualization agent in QueriLynx can determine the type of graph to be generated. For instance, in this example, as the generated query is dealing with time series data, the visualization agent has chosen to generate a line graph. Like earlier, the thought process of the answer generation and the generated and used SQL query is also provided. Now, let's ask a question that encompasses both of the tables in the database. When equipment utilization rate is 85% or more, what was the average resource utilization in the same hour? As the equipment utilization and the resource utilization data are in two different tables, the SQL agent generates a complex SQL query with a join statement. The result of the SQL query is interpreted, and an appropriate answer summary and graph are provided. In the intermediate steps explanations, you can notice the join statement used in the SQL query, the timestamps, and the actual SQL query after that. Now, let's see how DKube powers the DKube QueriLynx solution. The LLM being used by QueriLynx is deployed in DKube. Let's take a look at how to deploy an LLM in DKube. On the Deployments page, click on the Deployment Create button. Make sure the LLM deployment type is selected. Provide a unique name to the model deployment. As the framework type, let's select Kserve, as we will be using local resources to deploy the model. Let's select the NVIDIA A100 GPU instance for the deployment to be launched on. Check the Published option to make the deployment available for users of the same DKube setup. Click on the Next button. For this example, let's deploy the Qwen 2.5 Coder LLM with a custom model configuration. As the model source, select Custom LLM Model. In case of custom LLM deployments, you need to provide the model configuration YAML file via your DKube workspace. For instance, in this example, in the File Browser application in DKube, we have provided the custom configuration file for the Qwen 2.5 Coder LLM. The particular model being used here has been fine-tuned and quantized on the base Qwen 2.5 Coder LLM. This model is available on Hugging Face. Hence, on the deployment model configuration page, you will need to provide the Hugging Face token. In the configuration file, you can also adjust various model deployment parameters. Select this file on the model configuration page, and click on the Next button. In the advanced configuration page, provide the resource details to be allocated to the LLM deployment, such as the CPU cores, memory, GPUs, etc. Once done, click on the Submit button. The LLM deployment will begin. Once the LLM deployment goes into running state, it will be ready to use in QueriLynx. Click on the deployment name to get the deployment details, like the deployment configuration, the deployment endpoint, and the serving token. Once the QueriLynx solution is configured with the deployment endpoint and the serving token, QueriLynx will be able to make API calls to the LLM model, and the model will be actively used in the solution. This is how DKube QueriLynx lets you talk to your construction digital twin and get accurate insights instantly. Thank you.